Hello, and welcome to today's Lunch and Learn presentation, Analog Videotape Preservation, Best Practices and Options. My name is Scott Kiefer, and I will be the moderator for today. We would like to start with a land acknowledgement. We acknowledge that we live and work on the traditional lands of many indigenous nations. We know that indigenous peoples have suffered from historical and ongoing injustices and understand as an archival organization, we must work toward sharing historical truths and renew respectful relationships with indigenous communities. We respect the longstanding relationships that indigenous nations have to this land as the original caretakers. We are grateful for their stewardship and protection of the water and earth. We pay our respects to elders past and present. This is being presented by the Society of American Archivists, Archivists of Religious Collections section. The content in these presentations is for information only and is not legal advice. Our views do not necessarily represent the organizations where we work. We do not make any endorsements or guarantees. We are not liable for any loss or damage caused by your use of the content we provide. It is your responsibility to critically evaluate the content provided in the presentation or in any accompanying materials. Some housekeeping things. You will not be able to use your microphone or video during this session if you are an attendee. You can click on the closed captioning button at the bottom of the screen and under live transcript, click on enable auto transcription to get closed captioning. There will be a question and answer period after the presentation concludes. Please use the Q&A feature to ask your questions. We will not answer questions in the chat or unmute attendees due to time constraints. Please be respectful in your interactions. We expect you to follow the SAA Code of Conduct. If you have technical problems, then also put those in the Q&A, please. This session is being recorded. We ask that you please fill out the short survey after the session ends. And if you are not a member, we encourage you to join the Society of American Archivists. And we thank the Congregation of the Sisters of St. Joseph in Canada for hosting this webinar. Today's presenter is Libby Savage Hopfauf. She is the co-executive director at the Moving Image Preservation of Puget Sound and the audiovisual archivist at Seattle. And she is the audiovisual archivist at Seattle Municipal Archives in Seattle, Washington. Did I get that right? She works for both organizations and has done so since 2015. She received her master's in library and information science from the University of Washington and a Bachelor of the Arts in creative writing with a minor in sociology from Western Washington University. Libby, thank you for being here, and I think you get to take it away.
All right, thank you so much. So I will jump into my presentation. All right. So yeah, I suppose that now everyone knows who I am. I'm Libby Hopfauf. And I'm going to talk to you a little bit today about analog videotapes and some methods that we're using at MIPoPS and the Seattle Municipal Archives to preserve them. And I would like to start with a land acknowledgement specific to Seattle. I would like to acknowledge that MIPoPS is located on the ancestral homelands of the Coast Salish tribes, past and present, and honor with gratitude the water and land itself, along with the peoples and culture that have existed here since time immemorial and continue thriving here today. This acknowledgement is not meant to take the place of authentic relationships with Indigenous communities, but serves as a first step in honoring the land we are on. All right, so really quick, just to give you an idea of where I'm coming from with the different tools and methods that I'm going to discuss, I just want to tell you a little bit about MIPoPS. We're a non-profit 501c3 corporation, and we were formed in 2014 and began work in 2015 to help preserve cultural moving images by assisting local institutions with the conversion of analog video recordings to digital formats according to archival best practices. MIPoPS supports videotape digitization and preservation by heritage organizations with neither the resources nor expertise to address these at-risk materials. So we mainly work with regional nonprofits that have videotape in their collection, including documentaries, oral histories, artistic works, theatrical and dance performances, public works, industrial and educational content, what some people call orphaned works, or works that don't necessarily have a known owner or creator, as well as other footage. Over the past almost 10 years now, we have partnered with over 40 local archives, museums, historical societies, and heritage organizations, as well as local artists and art organizations to preserve videotape in their collection. To date, we have helped facilitate the capture and preservation of over 8,000 videotapes containing over 12,000 hours of content. On this slide, I have some logos from some of the groups that we've worked with or are continuing to work with. And our model is a little different in the sense that we're not necessarily a vendor, but each institution that we work with will provide a representative, may that be an employee or a volunteer, and they come into MIPoPS and we train them in analog to digital transfers for videotape. And that just enables each organization to preserve and provide access to their materials and further that broader goal of education about magnetic media preservation. And we believe that this makes our model a little more sustainable, as a growing number of archivists that we work with at various organizations are empowered to care for and provide access to their materials. And prior to beginning training with each group, we assess their goals and restrictions and tailor a workflow that best fits their needs and budget. So just really quickly again, the different services that we provide are hands-on training. We will digitize videotapes, also sort of like a vendor would, because we do understand that some people don't have the time or the manpower or capacity to come in and receive as much training as we would like to provide. And then we also provide needs-based long-term preservation, public access through Internet Archive, and we help with promotion and outreach, including screening nights that we host locally and virtually. We provide consultations, educational workshops, and we support the development of open source tools and training users. We also, we contribute to open source tools, as well as creating and maintaining digital and analog workflows tailored to our setup and to our partners' needs. But one thing that we are one of the many things that we're very passionate about at MIPoPS is providing documentation and resources that are openly available to the entire archival community. And we want to make sure that in order to deliver the most accurate information in an efficient and intuitive way, that we address all learning styles and skill levels. So that includes training videos, documentation like the examples on this slide, as well as written step-by-step instructions that are specifically tailored to our workflow, but could be applied easily to another one. So what I'm going to cover today is I'm going to talk a little bit about what makes magnetic media different from, say, film or audio. And then specifically, I'll talk about 3/4-inch U-matic, VHS, Betacam, and some of the DV formats like DV and DVCam. And I'll go over a little bit of inspection and risk factors to keep in mind when you're working with these materials, as well as proper storage of them and how best to appraise them. And then for some of the open source tools we use, just for the sake of time of this presentation, I limited it to the tools that we use for digitizing and quality control, as well as creating access files and caring for files long-term. There are a lot of other tools that we use or that are available, but these are the ones I'm going to mainly cover. DV Rescue, vRecord, QC Tools, the AV Artifact Atlas, Handbrake video tools, and LTO proofs. All right. So I'm going to dive into magnetic media. On the slide, you can see there's a comparison of videotape on the left and film on the right. And this is just to sort of provide a visual representation of what the main differences between these two. They have different makeups, as you can see, and I won't get into too much detail about the science that went into that. But the main thing that I wanted to impress is when you look at a piece of film, you can actually hold it up and see what's on there. You can't necessarily hear it, but you can see the waveform of the soundtrack if it does have optical audio. With video, it just kind of looks like brown tape. So you can't really see what's there. And this also kind of makes it so that it's harder to preserve that material as it becomes lost or damaged. So with a film, if it breaks, you can splice it back together and you can see where the frames are. Whereas with videotape, you're going to get significantly more loss of image because the tape is holding on magnetic information that's stored in there that then is read by the equipment that'll play back the sound in the video. Whereas with film, it's more concrete. And I won't get into too many nitty-gritty details about this either, but in addition to an audio and a video stream, DV formats also have a data stream, which contains a lot of really important metadata and information if it was recorded correctly, such as like the time code, the recording date, captions if they were created and embedded in the file. And then DV also has this really cool ability to sort of self-correct when it encounters errors, and it can try to like conceal them. And being able to record that information is helpful when you're working with these tapes so that you can properly preserve the data stream as well. Again, I won't go into too many nitty-gritty details about this, but one of the biggest things that makes videotape and audio tape different from film is that it's actively breaking down. If film is stored properly, it is relatively stable. It does have its own issues, and I believe there's a webinar about that coming up soon. But videotape, as soon as it left the factory, it started breaking down. In 2012, the Association of Moving Image Archivists, or AMIA, sounded the alarm that magnetic media collections are at extreme risk, and this has been characterized as a gathering storm. And the biggest problem with video is that not only are the tapes actively breaking down, the players that play them back are getting harder and harder to come by. So for every single one of these videotape formats that I have pictured on this slide, every single one of them needs most of them need a different player. And since that equipment is no longer manufactured, it becomes increasingly hard and cost prohibitive in order to get that equipment to play the videos back, as well as all the other equipment that goes along with properly preserving them. And this is all just to say that, like, though one of those things by themselves would be a problem enough, but the combination of that coupled with the fact that traditional archival training doesn't cover any, doesn't usually cover moving images and how to care for them. And so that lack of understanding and education creates that gathering storm. So all three of those things together. And that is all just to say that that's why MIPoPS exists, because we want to help save everyone's videotapes. So here's a really good example on the screen of a tape that's breaking down. When a tape is played back just normally, it will shed like this. So those little bits of black that are coming off of the tape, that's all the information. And you can't put that information back on the tape the way you could if like I said before, like if film rips or tears, you can splice it back together. And you can splice a video tape back together if it snaps, but any information that comes off of there is gone and it can't be retrieved or preserved. So that's just not to scare anyone, but just to impart the urgency that there is with caring for these materials. And really quick, I'm going to talk about identifying some of the different formats. Most formats have a logo on them that is located somewhere along the cassette shell. And I guess really quick, I should say, I'm going to say shell a lot and cassette. And what that is like there's, as you can see here through the little window, there's a reel with videotape on it. And that's the tape on a reel. And then the shell is the actual cassette that holds the tape together so that you can play it back. So this is an example of a Betamax tape. And it's just from that Beta logo. Most of them, as this is an earlier videotape, once things got a little further along, it's a lot more clear what the format is. And this can just be helpful for you either to know what type of equipment you need, or when you send things out to a vendor, being able to tell them what the correct format is really helpful. And it's also helpful to know what the media length is. And most tapes will have that somewhere on the cassette shell or on the case, although the case and the label aren't always the most reliable because sometimes people used different cases or different labels and put them on tapes. So you really want the ones that are etched or like actually on the physical cassette shell, like the lower ones on the screen here. And that's just helpful too for you to know like what the maximum amount of time could be on a videotape. And so that you can anticipate things like if something is an hour-long tape and then there's only a really short little video at the beginning, that just gives you an idea that maybe there might be something else on there that someone added, or maybe someone just wanted to record a 2-minute thing on a longer tape. These are just helpful tools for helping you plan preservation projects or communicating your needs to a vendor. For some cassettes too, the media length is located on the back of the shell, or there's a little door for the cassette. And these are the 4 formats I'm going to cover today: 3/4 inch U-matic, Betacam, VHS, and DV. And there are over, I believe it's over 40 different videotape formats out there that have been created. Some of them I've never even seen in the wild. These are just the ones that I've worked with the most at MIPoPS and SMA, and that a lot of people end up having in their collections for different reasons. And I'll go over those in a little more detail, but if you have questions about other video formats, there's lots of great guides out there. This is one of my favorites. Ashley Bluer has created these great illustrated guides to audio, film, and video formats, and they have a lot of great fun facts in them and helpful advice for identifying the tapes, and you can also use it as a coloring book. I guess I should also say at the end, the slides will be shared at the end, and I have a list of a lot of different resources that cover things that I do cover today and things that I probably won't have time to cover. So those can be really helpful too to help you in your research. So the first format, and one of my favorites, even though it can be very problematic, is U-matic. And this was the first videotape format that was in a cassette. Before that, the reels were actually like more like a film reel. They were separate from the cassette shell. And this made it a lot easier for people to take these materials like out into the world and record with them, because it meant that you could have a little bit less equipment. And this format was primarily used to store analog video, but occasionally it was used for the storage of digital audio. I've never encountered that, but I have heard of people doing that back in the day. Many early U-matics don't say U-matic on them, which makes it a little bit of an exception to the logo rule that I mentioned, but they do have a very distinct shape. And they are highly prone to sticky shed and loss of lubricant, which is another type of breakdown that the tapes can have. And I'll go over that in a little bit as well. Adhesive breakdown and soft binder syndrome. And the reason why they're called U-matic is because when the tape was loaded into a deck, it created this U shape, which is on the left side of the screen. So that was the way that the tape came out of the shell and wrapped around the player in order to be read. And then later, the image in the middle is showing Betacam and Betamax, and that used the B load that was shaped more like a B. And then after that, most videotape formats all ended up using the M load. And that's just to say that that's how that'll help you too when you're looking at a tape. Like the top 2 here are U-matic tapes, and the start of the tape looks almost like it's the opposite than the ones below it. And that's just to help you know if it's fast forwarded or rewound when you're looking at it. And then VHS was one of the most commonly used videotape formats, and probably one that we've all seen at least once. This format was developed initially in 1972, but it was canceled. But the engineers continued to work on it in secret until they had successfully working prototype in 1973. There was a smaller variant, which is pictured on here, the littler cassette, called VHS-C for VHS Compact, and it was introduced in 1982 for camcorders, and these tapes can be played back in standard VHS machines with an adapter. And this format was developed with the following goals: to be compatible with any television, to be compatible across all manufacturers, have the ability to be customized and expanded, be inexpensive to purchase and repair, and have parts that can be easily replaced and maintained. And then later on, there were the introduction of S video, and that allowed for slightly better video quality, but it stood for Super VHS. And that was because they thought that it looked a lot better, but it didn't really. And I'm not going to talk too much about that one specifically, but it does need to be played in a different player because it requires an additional set of heads and able to read all of that extra information that was added. And here's an example of the adapter that you can get to play VHS-C in. You can also play it back in a camcorder if you have it, but for digitizing, it's much easier to use an actual video player. And then Betacam was released in 1982, and it was a high quality broadcast format. So VHS was definitely made more for consumers, which had a really amazing democratizing effect, whereas Betacam gave reporters and news gatherers the ability to work with a lighter, easier to transport, but still high quality format. And it was a lot of the time, because it looks so similar, people will get a little confused if they have a Betamax or a Betacam. I am definitely in that camp. The first time I encountered Betamax, I didn't understand why it wouldn't play in my deck. But Betacam came in several different formats after that, and Betamax came before it and was very similar to VHS in the sense that it was cheap and easy. Most people used it to record TV. Betacam was a huge improvement and was used mainly by professional filmmakers. It was similar to U-matic in the sense that all the sizes, there are all these different sizes, but all of those different sizes can be played back in the same deck. And like I mentioned, there are a couple other things that came after that. There was Betacam SP, which was slightly better and just had an improved video quality. There's digital Betacam and HD cam, and those both contain a data stream like DV does. And the easiest way to tell the difference between these is to look for that logo, like I mentioned, and that's just going to let you know whether or not you can play it back in your player based on what compatible formats you have for each player that you. And then last but not least is DV. This format was launched in 1995 as an affordable and compact digital videotape. Using digital videotape greatly simplified the production process compared to analog videotapes. The ease of use, affordability, and compactness of DV enabled many communities within heritage, journalism, and arts organizations to integrate video into their culturally significant work. DV was popular between the mid-1990s all the way through the late 2000s. I actually just got a tape the other day that was recorded on DV from 2015, so people kept using it for a really long time. And then some of the advantages, such as the lower cost, the size, and the simplicity of it, enabled a lot of those communities, like I said, to use this and to start recording their own stories in their own voice. But because of that, DV tape was and is extremely fragile and highly sensitive to contaminants and self-deteriorates at a rate much faster than other analog videotapes. So they ended up not really knowing, but making a sacrifice for the integrity of the actual medium in order to make it easier for people to use. But manufacturers didn't really understand that videotapes were breaking down in general when they were being manufactured. And this is just to say that it has a little bit of its own quirks and can be really hair-pulling and frustrating, but it can also be a really great format that looks really good. So a lot of different formats had different recording modes, and this just throws another wrench into the works. Um, SP stands for standard play, and then you could, with certain formats, increase how much content you could record onto a tape. And what people were basically doing was recording at a slower rate so that more things could be squished onto the tape, and that resulted in a loss of quality. So the more you ramped up from standard play to LP, which is long play, or EP, which is extended play, the more you're going, sorry, the more that ramped up, the lower quality the video was, but there was a lot more content on there. So a lot of people did that, especially for recording off of television or for sort of getting a ton of like home movies onto a tape. And so they can be really tricky and difficult to digitize because the quality is so low. And a lot of the time they were like jostled around or different things like that as they were being carried around on vacations or on journalistic endeavors. Um, but that's just to say that they have their own issues that need to be addressed. But if you encounter a VHS tape that looks like it's like playing and it's all sped up, that's highly likely because of it was recorded at a higher mode and it needs to be played back in a different deck. And I have a lot more details in the slides about all the weird little fascinations and different things that came with different recording modes for all of these formats. So please feel free to check them out. For inspection, all videotape has a set of risk factors that come into play, like any other archival materials. So the format is a risk factor for the quality and the manufacture date. So the older a tape is, the more likely it is to be at risk, but also the lower quality of the format makes it more at risk. So even though VHS and DV came out a lot later than, say, U-matic, they are still at really high risk of damage because they were so fragile to begin with. And then the older the tapes are, the more likely they have either not been stored properly, and they've also just like had more time to break down and more introduction to like just the regular environment, which has caused them to develop things like deterioration. And this is something that affects all videotapes. So and this is just referring to changes and damage to the materials. And then another huge risk factor is the historical content and unique material that can be recorded onto those tapes. A lot of the time, especially with DV, you will end up with duplicates in your collection, but with DV, a lot of the time that's a camera original. Like that wasn't something that I would go to like Blockbuster and rent an DV version of like The Little Mermaid. So a lot of the time it was something that was probably recorded of not like a final, like it can be a final production, but it was probably created by the people who have it or was a copy of something else. It wasn't widely distributed. And then there are different types of deterioration. There's physical, so that's changes in the size and the shape. There's chemical, which is changes to the structure of the videotape and the cassette that holds it. And then a whole other one is biological, so organic attacks such as pests or outside factors that can come into play. And some examples of those are sticky shed. This is one of the most common afflictions that a lot of the time people just thought was mainly found on U-matic or 1-inch tape. But at this point, I think I've seen every single video format have at least a little bit of this. And it seems to also, in the archival community, we've been talking a lot about how it feels like it's getting worse and worse and worse as time goes by, especially over the last 3 years. So the likelihood of contamination being present is higher, and the amount of contamination, and then the amount of work it takes to remove that contamination in order to be able to play back a tape. And sticky shed syndrome is referring to a breakdown of the binder. So a videotape in that first slide that, or one of the first slides I showed has several different layers. And what this is it's a breakdown of the adhesive that holds the actual magnetic material onto the tape. So when that starts to break down, it develops this really gross kind of gunky substance, and it is holding the tape together. So the tape isn't able to play properly, which means that you can't put it in a deck and play it back or see what's on it until after you've decontaminated it. And then very similarly, there is also adhesive contamination or breakdown. This can come from many different things. It can come from a breakdown of the adhesive that held like the label stickers onto the tapes, or the adhesive that's holding the tape guides on inside of the tape shell. There's an example of that in the bottom middle on this slide. That's a tape guide that's been contaminated within the cassette, and that sort of like holds the tape in different positions so that it can be played back on the deck and then can be held in place and be transported safely. But that breakdown can look really similar, but it needs to be addressed slightly differently than sticky shed syndrome. It usually requires cleaning in addition to baking, and I'll talk more about both of those in a moment. But they can look very similar, so it can be very frustrating if you're trying to use one method when really it's another. But the easiest way to see it is it ends up being more of like a gunky, like dark, like amber color almost, especially when it's cleaned and removed, where a sticky shed is very, appears white on the tape, and then when it's removed, it's more of like a dark brown. You can get mold from many different factors. A lot of the time, just moisture in the air, especially like where I'm at in Seattle, people stored tapes in their basements or in their attics, different places, wherever like archives or individuals could find to keep them safe. And a lot of the time that meant that they weren't climate controlled. So mold is a huge problem and will need to be removed in order for a tape to be played back as well. Here's an example of physical damage. This is a scratch. This can happen sometimes if a camcorder was dirty when someone was recording with it, it would end up scratching the tape in intervals, which means like even as it was recording, it was damaging itself. It is really hard to deal with, and sometimes certain decks won't let you play those tapes back. They are really sensitive to any sort of warping or anything like that. So if a deck is playing just fine and then stops, that this could be one of the problems that you're encountering. There's warping. This is usually also caused by heat or moisture. The tape ends up like this being warped, which is hard because when it's being threaded through the machine, it's not sitting properly. So it ends up getting a weird warble or having what's called tracking issues, meaning that the deck isn't able to properly, consistently track the tape as it plays back. And this and scratches are kind of something you can't really do anything about. If this warping is caused by moisture, you can try baking it to remove some of that moisture, but your playback is still gonna be not that great, especially if it's as far gone as this poor tape was. There's stepping, which is pictured here. It's kind of hard to see, but it's similarly to film, you want a video pack to be smooth and flat. And stepping can come from many different things. It can be a tension issue where the tape isn't being held inside its cassette shell properly. It can also be from sitting improperly. So, and I'll show some examples of this later, but if a tape is sitting flat, like it is in both of these pictures, over time, gravity takes over and the tape can become stepped like that. And that can also cause playback issues because the tape isn't able to track consistently. So it's a best practice with all tapes, once you've removed contamination, to make sure that you fast forward them all the way and rewind them all the way. It's called repacking, and that just sort of helps reset that pack to a nice smooth, even, consistent height, and then allows it to play back properly inside the deck. So all tapes are prone to shedding, no matter what. That's part of the issue when I say that tapes are breaking down. A really famous example of this that I actually just heard recently is when Fleetwood Mac was recording the Rumors album, they had to immediately create a duplicate of the tapes that they were working with because the ones the original recordings were on were becoming damaged because they kept playing them back. And that was with brand new tapes shortly after they were manufactured. So if you imagine that, it's sort of like if you keep washing your clothes over and over again, they start to break down. A tape, no matter what, when it plays back, is gonna break down. So the more it's used, the more it will break down, or if it's more fragile or in worse shape. But so then you might end up with some of these like larger parts coming off, like in the bottom right-hand corner on this slide. That was actually caused from a tape being misaligned, and then one of the parts inside the machine was actually like scraping off pieces of it. So that's not necessarily normal shedding. That's definitely damage from a machine and a tape not being properly calibrated to work together. But the other ones where it's just like little flecks all over, that's just normal shedding. And that's that information I was talking about that can come off the tape and then you're not able to retrieve it. So I'm going to play a little video. So with some of those contaminations, you can tell right away just by looking at them that they need to be baked or cleaned, but sometimes you won't know until a tape is inside a deck. And if you encounter any of these things, you're going to want to stop and reassess the situation to decide how to proceed or what sort of care these tapes might need before being played back or digitized. So this video has some different examples of these things. And the first part is normal. So this is like an okay thing to see. And this is just a Betacam tape loading normally into a player. And the rest of these are tapes that are contaminated or damaged. They're making not very good noises, and they also aren't moving smoothly through the tape path. So if you encounter any of those ones, you're gonna want to take the tape out because it's likely contaminated with something that's like not immediately observable, but is probably deeper inside the tape and is not allowing it to properly move or be played back. Oh, and then there's physical damage. I do not know what happened to this tape. It came to us like this, but it looks to me like it ended up getting stuck on part of a machine. And then instead, some machines or a lot of machines will stop when it encounters like a weird tension issue, but sometimes it can't stop itself in time. And so this one just got like kind of pulled up and wrapped up around itself. This is also something you can't really fix. All of that part of that tape that's crinkled and damaged will need to be cut off, and the tape will have to be spliced back together, and you won't be able to retrieve that information from the tape because the deck won't play back something that is that uneven because it could cause damage to the deck. So most decks have built-in mechanisms to protect themselves and to try to protect the tape, but a lot of it is to protect the deck. And then there are a lot of different ways that you can clean tapes. There are fancy cleaning machines, which I've wanted for many years, but they're very, very expensive, and most smaller heritage organizations won't be able to afford them. But there are other manual methods that you can use to remove contamination, because most tapes, especially at this point, really need to be cleaned and or baked prior to being played back. And the decks will also need to be cleaned regularly. If a tape is very contaminated, you might even need to stop during playback and clean the tape, the cassette shell, and the deck in order to get it to continue playing, because even though it's been decontaminated, it will start to like slough off more, it'll shed more, and it'll slough off more of the contamination that's still adhered to it. And that can block the videotape heads from reading the material on there. But we have cleaning supplies and recommendations on our website. And this is a manual way that we've cleaned tapes before. It's very tedious, but sometimes it's the only way to get a tape to play back. Especially if it's like really covered in a bunch of gunk deep inside like towards the center of the cassette shell. It won't, by baking some of those, it doesn't actually like remove it, or dry up the contamination all the way. You have to get in and wipe it off like I was showing in the video. But it works. We also sort of wrangled some tools together and used one of our lower quality decks to create a cleaning machine. It's not the same as the fancy ones, but sometimes it will do the trick and it's a little less tedious than doing the manual cleaning. But both of those are effective. They're just very time consuming. And then baking, what baking basically does is it removes the moisture that has built up in the tape, and it will allow you to then clean the tape, repack it, and capture it. We bake tapes for, it used to be 48 hours, but now we usually bake them for at least 3 days at a temperature of between 125 and 130 degrees in a dehydrator. And we just got a cheap one off Amazon that was recommended by other audiovisual archivists. So there are cost-effective ways to do this without having to get like a big fancy archival like industrial oven. But it does help. You have to remove the tapes from the shells and then put them in the dehydrator, let them cool down, and then you have about 24 to 48 hours to process them before you end up with contamination that starts to build back up. Tapes can tear and you can splice them back together with tape. We have different repair guidelines and videos, but it's sort of one of the easier things you can do in-house for a minimal amount of supplies, but it is time consuming and frustrating, but very similar to splicing audio tape back together if that's a repair that you've ever dealt with. For storage, you want to make sure that tapes are in a safe spot. Don't drop them. You want to make sure they're free from dust, water, heat. You don't really want to have magnets around them because that can demagnetize the tape and remove the information from it. You don't want to touch the tape because the oils from your fingers can cause additional breakdown and problems with playback. And you don't want to store them flat. So you want your tapes to be inside a case, preferably. You'll want to make sure to disable the recording mode so you don't accidentally record over them. And you'll want to make sure the tape is always all the way fast forwarded or all the way rewound when it's stored. When a tape is stored, it puts pressure on that part of the tape. So you want to make sure it's at the very beginning and end where there's likely not any information. And that way that stress is not put on something that has valuable content. And then you want to make sure that your tapes are upright. So they can be stored upright like this, or the first check on the slide here, or upright like the second check. You just don't want them to be flat. And it's easy to remember because video equals vertical and film equals flat. Those are the best ways to store them. And then for appraisal, like I said, you'll want to make sure to disable the recording mechanism for everything. Each format of tape has a different odd way to do it, but most of them come with a little thing on the inside that shows you how. You can also find it online, and most format guides will show you how to remove it. U-matics have a cute little red button that you pop out, which is kind of fun. And then you'll want to make sure that you have proper playback equipment that's compatible with the formats that you're working with. A lot of manuals can still be found online for different equipment, for different videotape decks, which is really helpful to know what they're compatible with, what their different quirks are, and can also be really helpful if you're looking for someone to repair them, to know if they work with a different brand or a certain brand or a certain model. And can help make sure that at least inspect the deck and make sure it's up and running and won't damage a tape before you have a chance to digitize it. For format selection, that's another thing. If you have a duplicate of something, you'll want to make sure that you have a higher quality or the most original format. So I've even seen instances where people will digitize videotape to film. That film would be fine to keep it. You're going to want to keep the original or as close to the original as possible. A VHS copy is not going to look as good as the Betacam original or even a Betacam duplicate. So open source tools that we use at MIPoPS to work with these materials. I want to point out one thing. This is a slide that's taken from our website. And I just want to note the first sentence that acknowledging that technology is constantly changing and must adapt in order to maintain our commitment to our values. And that's just to say that like open source tools are really great and can be very customizable and really helpful and cost effective, especially for digitizing workflows, but they do require a little bit more engagement or time or tailoring and tinkering to get it to work well. There are great resources out in the community for all these different tools. It's really helpful to go on GitHub. I think almost every single open source tool that we use has a GitHub page, and the issues tracker is really helpful, even if an issue has been closed, because a lot of the time people will describe in detail problems that they're having, and you can kind of compare and contrast and see if that's maybe your same problem and see what steps they took to fix it. And then there are usually also additional resources and documentation that are out there for different things. This is an example of a format guide we have for the DV Rescue project to help people get set up and going. And then not all, but most open source tools have troubleshooting sections where they will walk through different issues that you're having. While most open source tools don't have like a IT department, you can't call someone and tell them your problem. It's usually just archivists and developers working to create something in a community, but that also means that you get to provide feedback and make requests and ask people to fix things or incorporate new features that would be helpful for you. And then at MIPoPS, we also try to provide training videos for all of the things that we do. So that's another option as well. And at MIPoPS, we use a lot of different open source technology, but the main ones that we use for digitizing are Videorecord and DV Rescue. So for digitizing, these are, oh, last one. There are 7 basic steps that we've gone through most of them, the appraisal, proper storage, but now I'm going to talk a little bit more, and I know I'm running short on time, but about adjustments and digitizing them. So here's an example of a setup you can have for analog video equipment. This is at the MIPoPS office, and we have a lot of different players and decks, and they're all hooked up to a time-based controller, which allows you to make adjustments to the image and audio quality to ensure that you're getting the best possible capture and that it's the closest it can be to the original intention of the creator. And all analog formats need to be run through a time-based controller in order to stabilize the video. That was built into some decks, but a lot of the time that's not working, and it's better to have a separate component that you can fix separately and operate separately in order to get the best possible quality. And it also gives you a lot more options than traditional time-based controllers that came with different decks. So we have those all routed into a patch base so that we can pick the audio and video signal that we're going to use, and then we digitize to our computers through a Blackmagic video card. So Videorecord is a really great open source tool that provides visualization of the video playback that you can use when before and during capture. In this picture here, it's showing the numerical visual view, which is showing you the different levels for the color and the lights and the darks, as well as some of the other components that make up the color and the sound for the video signals. And that's just helpful to make sure that like you're getting them within a range. So here's an example of some videos have color bars, and that allows you to see how that videotape was calibrated. And that makes it the easiest way for you to make those adjustments. So in this image, the lower part of it has separate waveform monitors and vectorscopes for monitoring the darks and the lights and the colors. And one great thing about Videorecord is you don't have to use that extra equipment. You're able to just use one program that's sort of all encompassing and is giving you feedback about the image quality. And then another great tool that you can use in combination with vRecord is QC Tools. And this is a quality control tool that was created by Bayback Media. And it allows you to take a captured video file and run it through this program, and then it provides a graph layout of all the same things that you were looking at in vRecord, but instead of just seeing what the image is doing at the time, it'll show you the entire length of the recording so that you're able to see if something went wrong and maybe you need to recapture. So for example, from this graph, I was able to see that this one video was undersaturated. And so I was able to make some adjustments and come back and redigitize the video and get the full range of color that was originally recorded on the tape. And this is another example where this video was thought to have been black and white, but it was actually in color. So from using the different graphs and the amazing documentation that's been created for QC tools, I was able to fix that and recapture the tape. And QC Tools is a really great training tool also that sort of helps you just develop an eye for those sorts of things so you're able to understand what the problem is and how you can fix it, or if it's something that maybe you can't fix. And then DV digitization is a lot more simple and straightforward. All you really need is a working deck, working FireWire cable, and maybe some adapters in order to hook it up to a computer and capture it like that. You don't have to have a time-based controller or make any adjustments. The data stream, the video stream, the audio stream are all contained within that DV stream, and that you can take just with the one cable and possibly a couple adapters and capture all of that information directly to your computer. And MIPoPS has helped develop DV Rescue, which is a capture software that allows you to actually read that data information stream that is contained on the tape, as well as the other, the video and the audio, and then it'll help provide information just like vRecord does to give you an idea if something is going wrong with the tape, and if so, how you can correct it by using its other features. I think I'm at time, so... Um,
Do
but
you
oh,
do you want to give a quick wrap up here if you're getting close?
sure, yeah. So yeah, I apologize. I had more slides. Um, but the slides will be shared. I have some recommendations for file formats in here, as well as like different ways that you can use the AV Artifact Atlas, which is a really great sort of manual that you can use in conjunction with QC tools, in order to like spot different issues that are happening on the tape. And like I said, correct them or just know what's going wrong, and make note of it in the metadata for the recording. But yeah, all of these for DV Rescue, vRecord, QC Tools, and AV Artifact Atlas, they all have really great resources online. And I have them linked at the end of the presentation. Yeah, thank you so much for having me. Sorry I ran out of time there.
No problem. Thank you very much. We have time for a few questions here. This is from someone with a problem. The cellulose bands from the dictaphone have fungus. They are isolated in Ziploc bags. Any suggestions on how to handle and remove the fungus?
Dictaphone, that's been my new battle recently. I when I've encountered fungus, I haven't encountered that specifically on dictaphone, but I have seen it on videotapes, and it's great that it's isolated. I would recommend cleaning it with a cloth and just a little bit of isopropyl alcohol to like wipe some of it off of the edge. And then you can bake those tapes to remove more of the moisture that's sort of letting that fungus thrive, and fast forward it and rewind it to get some of it off. But I would definitely wear a mask and gloves and do that in as isolated of an area as you can. I've definitely wheeled decks outside to clean them and to clean tapes.
You partially answered this one then. Is it okay to use 100% isopropyl alcohol on magnetic tape and you question mark, and you clean both sides, including the mag side? Question mark.
Yes. Yes to both of those. You do want to make sure you clean both sides because the contamination will build up, and then sort of press the two sides together. So even though like one of them is more prone to um, that breakdown, all of the contamination needs to be removed. Otherwise, it'll get stuck in the deck or create other problems. And then yes, 100% isopropyl alcohol or denatured alcohol both work great.
For cleaning, is it enough to clean the edges of the wound tape, or do you need to clean the whole tape surface?
You need to clean the whole tape surface. The edges can get particularly gross and will create some of those alignment issues that I mentioned, but and having dirt on any of the surface or any type of contamination is likely to rub off and could either damage a deck or it will cover the videotape heads. So when it's going past, it's kind of like smearing something across a windshield, like you wouldn't be able to see out of it. So by removing all that, you're containing more of it.
If you don't see any shedding inside the shell of a tape, presumably, is there a quick method to determine if a tape has sticky shed before you put it in a playback deck?
Yeah. Oh, I actually skipped this. I'm sorry. Before putting it in a playback deck, you can smell it. Again, you'll want to wear a mask. But tapes that are contaminated will smell either like really cheap candle wax or like I don't know if anyone else made those little mosaic things with melted crayons at Sunday school. But those will that weird kind of like cheap waxy smell that can be in there. Some people say that they think it smells like gym socks or like an old musty gym bag. Um, but the one that I noticed the most is the crayon smell, but it probably just depends on the level of contamination and what your nose smells. But yeah, anything that smells kind of weird or chemically or musty is an indicator that something's going on.
Does rewinding or fast forwarding run the same risk that playback does?
Uh, yes and no. When a tape is being fast forwarded and rewound, it's going faster, but it's not being pressed, which like and that speed can potentially cause problems. But it's disconnected from like it's not being pressed against the heads, so less parts of the machine are touching it, and that reduces risk of both the tape getting damaged and the deck getting damaged. And then for playback, it's going a lot slower, but it's going through the entire tape path of the deck. So it can get caught in different places and different things. One thing you really want to make sure you don't do is while a tape is playing, press fast forward or rewind, because then it's pushing the tape still against the video head and moving at a faster rate.
And I think there's time for one more. Given the paucity of experienced technicians and parts, what is MIPoPS doing to address maintenance and repair of legacy video decks? And this could be MIPoPS or any other group like them.
Sure. Yeah. So for us specifically, we have a really great relationship and we're very lucky to have it with a video engineer in Seattle. And he's actually the sound engineer for the Seahawks and the Sounders. But he's been working on videotape for years and he's really great. We'll bring him, I always tell him I need his stamp of approval before I'll use a deck. But by taking our decks to him, he'll inspect them and then give us feedback, like if something's worth repairing or not worth repairing, just based on the scarcity of the parts or the quality of the deck. He'll also take different decks and mix and match them. So take a good part from one deck and put it in another if that works. There's been some talk occasionally, and I really am hoping to learn more about this year at a conference that I saw it listed on. But over the years, people have talked about 3D printing parts for decks. So I think that's encouraging because some of them are really hard to find, the different parts. So I hope to learn more about that and hope that that conversation keeps going. But I think a lot of people that I talk to are doing the same thing we are. They collect decks and will mix and match parts and find a trusted person to help repair them. And we're all also trying to like encourage people like that to sort of uh, out like open up that work that they do and their methods so that archivists can do some of the lower level repairs. Like I'm not an electronic engineer, but there are certain things that I've been taught over the years that I can do myself, and just like having that knowledge more widely available, like I think a lot of us are hoping will help with that, but it's definitely a concern.
Sure. Libby, thank you very, very much. We would like to give one promotion that 2 weeks from today, on the 17th, will be the final Lunch and Learn of the year on film preservation, which will be with Hannah Palin, who is also of MIPoPS. So we hope to see many of you there. And Libby, thank you very much for your time.
Yeah, thank you. Sorry for going over.